Good morning to all. Myself K.Rajkumar, Assistant Professor in Civil Engineering Department from BSB Engineering College, Karur. I would like to share my knowledge about soil mechanics. So the subject code is 23 CET 404, soil mechanics. So these are the contents of first unit. Unit 1 is a soil description. So this unit mainly describes the formations and soil descriptions, particles shape, size and colors, and the compositions of mixed particles, that means gravel, sand, silt and clay particles, and particles behavior and soil structure, phase relationship of soil, the next index properties and the significance and classification system of BIS and unified soil classification system. So let me see one by one. The first one is the introduction of soil mechanics. Normally the soil is a complex material which is formed by weathering of earth. So weathering means initially the soil disintegrate and its weathered, after it is should be transferred, and after the transportation it should be a deposit of some much area. After the deposition the upheaval are formed. So finally the soils are originated. So the soil mechanics it deals about the laws of mechanics in the soil. Okay, so soil mechanics, it's very essential part to design the foundation as well as the earthwork designs. And let me see first one, origin of soil. I already told that it is formed by weathering. So weathering means it is a disintegration of rocks. Disintegration means it's a breaking of rocks into the smaller particles. The parent rocks should be weathered and it should be breaking, and it get into the smaller particles. So weathering, transportation, deposition and upheaval. So these four things are periodically, it should be repeatedly, it should be occurred in the environmental cases. So it is a geological cycle. Next one is the types of weathering. So the first one is a physical weathering. So physical weathering means the temperature changes, frost acts and abrasions. So these are the physical weathering. So because of a physical weathering, the soil should be disintegrated of particles. Gravel and sand and boulder is the best example for physical weathering. Next one is a chemical weathering. It is a reaction in between the soil particles. So the example of oxidation, carbonation and hydrations. So mainly the clay and silt particles are formed by this much of one chemical weathering. Next thing is a biological weathering. By the action of roots, plants, microorganism inside the earth, the soil should be formed. So this is called as a biological weathering. So next one is a soil description. So initially we have to uh, identify the soil. The soil identification is mainly useful before starting the constructions. So the soil description is mainly the visual or manual examinations are there. It includes the size of particles. Size of particles means the grain size. The next one is the shape of particles. What are the shape? And next one is the color. What is the visual color? And next one is the texture and consistency. So based on that, the soil are described. So the next one, particle size classifications. So in that case, so based on the size of particle, the soil should be categorized. If the soil particles are less than 0.002 millimeter, that means 2 micron size, the soil is classified as a clay. If it is a ranges of 0.075 millimeter to 0.002 millimeter, means the soil categorized as a silt. And next thing, above 0.075 millimeter, the soil is classified as a sand up to the size of 4.75 millimeter. So above the 4.75 millimeter, the soil is classified as a gravel portions. So next one is the shape. So based on the shape, the soil should be categorized. For example, in the transport, when the soils are transported by means of a river, the deposition somewhere in the end of river shows the deposits are there. So in the deposit regions, the soil like the shape like a rounded shape, rounded aggregate, sub-rounded aggregate, and the broken rocks it should be get at the angular shape of aggregate. So the shape of aggregates mainly depends upon the modes of transportations, modes of origination. Okay, so next one, the shape is mainly affected by the shear strength of soil. It is a major parameter of soil, so which only deals with the engineering structures. The next one is the compaction, and another one is the interlocking of soil particles. So then the next thing is the color of soil. So the color mainly it should be represented the mineral composition of soils. So what are the minerals are there? So based on the visual examination of color, the soil should be categorized. So if it is a black soil means the organic matter should be maximum here. And next one, it's a red or a brown color means the iron content, that means iron oxide, Fe2O3, that means the iron oxide should be maximum. If it is a gray or a blue color means it should be anaerobic conditions and it should be poor in iron oxides. So next one is a composition of gravel, sand, silt and clay. So based on that, every soil it should be ranges of this much of main portions: gravel, sand, silt, and clay. We already discussed about the sizes, particle sizes of these four things. So the next thing, the grain size, it should be ranges based on the size. So the soil particles, the grouping into the boulder, cobble, gravel, sand, silt, and clay. So the dimensions, the each sizes are as indicated here. If the soil size is greater than 300 mm means the soil size is called as a boulder size. If it is a 20 to 80 mm means this is called a coarse grained gravel soil. If it is a 4.75 to 20 mm size of soil means it is called as a fine grained gravel. If it is a 2 to 4.75 mm ranges means the soil is categorized as a coarse grained sand. If it is a 0.425 to 2 millimeter size of particle means the soil is described as a medium grained sand. If it is a 0.002 to 0.425 means medium, that means a fine grained sand. And next, if below the size, that means 2 micron means that it should be called as a silt and clay. So these are the composition of gravel, sand and silt. And next one is the particle behavior. What is the behavior of particle? If it is a clay particle means each particle has some attractive forces, it should have some cohesion. So based on that, actually based on the particle size, shape and surface area, it has some behavior. So based on the behavior, the attractive forces are developed. So because of forces, the cohesion should be developed for the particular type of soil. The cohesion also is the best parameters to develop the shear strength. Normally shear strength is mainly depends upon the cohesion and the angle of internal friction. So cohesion is the main thing. So it should be directly proportional to the shear strength of soil. If it is a greater cohesion means the shear strength should be maximum. So shear strength means the load capacity of soil, particular soil. Okay, next thing we discussed about the soil structure. So it is the arrangement of soil particle, that is called as a structure. If it is a single grained soil means it is a equal ranges of soil particles accumulated in the particular soil. If it is a honeycomb means some air gap should be formed in between the soil structure. It should not be in a uniform manner. Next one is a flacculated soil structure means it should be the soil structure should be parallelized structures. If it is a dispersed structure, it should be seen in the freshwater clays. Okay, so flocculated and dispersed. So these are the soil structure. The main thing, this one is a three-phase system. Three-phase system. Soil as a three-phase system. Initially, the soil has solid. Next one is a water. And next one is a air. Uh, Okay, the soil has a three major portion. One is a solid, next one is a water, and next one is a air. I just differentiate both of them in respect to weight symbols and volume symbols. The solid weight can be represented as a W suffix of S, and the weight of water can be represented as a W suffix of W, and the air content may be represented as a weight of air. We know that air, there is no weight here, right? Yes, so there is WA, that is equal to 0. So the total weight of water WW, that is equal to weight of voids. Normally, the soil has a two functions. One is a solid portions and another one is a void portions. Void means in between the soil particle, the gap should be called as a voids. The voids is accumulated by the air and water. If the water fully accumulated in the solid particles means that is called as a fully saturated soil. If the air is fully accumulated in the voids of solid means that is called as a dry soil. That means dry saturation. There is no much of water in between the solid particles. So the weight of soil, it should be equal to Ws plus W that means volume of solids plus volume of voids. So the volume of voids can be represented as a W of W, that means weight of water. So totally the W equal to Ws plus WW. In terms of volume means the volume of solids can be represented as a Ws, and the volume of water can be represented as a WW, and the volume of air can be represented as a VA, sorry, Vs and VW and VA. So total volume of soil structure can be V equal to Vs plus Vv. That means volume of solids plus volume of voids. The volume of voids, that is equal to Va plus Vw. That means volume of air plus volume of water. Air, there is no weight, but it has some volume. Okay. So Va, that is not equal to 0. WA, that is equal to 0. We already told that. But VA, that is not equal to 0. So VV equal to VW plus VA. So finally the total volume of voids V equal to Vs plus VW plus VA. So initially we have to know about the difference between them. So one is a weight of solids, weight of soil, the total weight of soil W equal to Ws weight of solid plus weight of water WW. And next thing, total volume of soil V equal to weight of solid, that means Vs plus weight of water Vw plus weight of air Va. So next discussed about the phase relationship. So I categorize under five phase relationship. The first one, relationship between mass and weight. Mass means M, weight means W. And next thing, relation between mass and volume. First one is the relation between mass or weight. Okay, anyone, mass or weight. Next one, relation between mass and volume. So included of mass and volume. The next relationship is weight and volume. And next one is the density or unit weight. And last one is the relationship between volume. Let me see one by one. First one, relation between mass or relation between weight. So water content, it's a major index properties of soil. So initially we have to know about what is the water content present in soil. That is only affect the shear strength as well as strength parameters. So normally the water content denoted as a smaller W. So it should be equal to weight of water present in soil to the weight of solid. This is the ratio. The ratio is called as a water content. Otherwise, it should be represented as a ratio of mass of water present in soil to the mass of solids. It is always expressed as a percentage. We take it as one example here. Normally, the total weight of wet soil, total weight of wet soil is 200 gram. I just kept some weight balance. After that, I take the measurement of 200 gram. After that, I kept the soil sample in the hot air oven. Nearly 1500 degrees Celsius oven is there. So I just heated of soil sample. It should be dried the water content. So after fully dried soil sample, I just take another one more reading. That means weight of dry soil, that is equal to 160 gram. So initially the weight of soil is 200 gram. After dried portion, the soil weight should be less because of the water should be evaporated. So the weight also should be evaporated. Weight of water should be evaporated. So 40 grams are evaporated. So that means water only evaporated from soil, right? So the 40 grams should be evaporated. So the water present in soil, that is equal to 40 gram, and the weight of solids is 160 gram, because after evaporation solid is only present in soil. Okay, so water content, normally we know the formula. That means total water present in soil, the total weight of water, total mass of water present in soil divided by mass of solids into 100. So 40 divided by 160 into 100, it is equal to 25 percentage. So that particular soil has a water content of 25 percentage. So first we know about the water content. So we know we have to calculate the water content of particular soil. Next thing, relation between mass and volume. Mass and volume, both are is different. Normally, mass by volume, that is equal to density. That is equal to density. Bulk density means it is a total mass of soil to the total volume of soils. Next one is a dry density. So dry density is a ratio of mass of solids to the total volume of soil. The next one is the density of solids. That means density of solids means mass of solids to the volume of solids in the soil mass. If it is a saturated density means the total mass of saturated sample to the total volume of saturated sample. So if it is a soil mass entirely saturation means the total mass by total volume can be represented as a saturated density. The next one is a submerged density. Normally submerged density, it is also mass of submerged solid particles to the total volume of solids. So mass by volume should be denoted as a density. Mass by volume, that is denoted by a density. The next one, relation between weight and volume. So the ratio of weight by volume should be taken as a unit weight. Unit weight is equal to total weight by total volume. That means bulk unit weight. Dry unit weight means weight of solid by the total weight of soil mass. That is called as a dry unit weight. Dry weight of unit weight of solid means weight of solids to the volume of soil solids. And saturated unit weight means weight by total volume of saturated soil sample. If it is submerged means excess water. If it is fully saturated means after pouring of water should be occupy some more volume, some more excess of volume here. So that excess of water should be added to the soil sample means the soil sample is called as a submerged soil sample. So submerged unit weight. The next thing, relationship between density or unit weight. Density or unit weight. The ratio, the main thing is the specific gravity. So the first index properties is a water content we already discussed. So the next index property is called as a specific gravity. It's a major parameter while choosing the soil. Different types of soil has a different specific gravity here. Normally specific gravity, it should be find out it is the ratio of a unit weight of soil salts to the unit weight of water at the same volume at the standard temperature. If it is a in terms of density means density of soil salts to the density of water in the same volume at the standard temperature. Normally in the laboratory the soil specific gravity should be determined by the pyconometer. So based on the pyconometer equipment we categorize the soil by specific gravity value. Normally it should be ranges from 2.6 to 2.75. So next thing is a relation between volume. Relationship between volume means based on the volume the soil should be categorized of some more parameters. So the first one is a void ratio. Void ratio should be represented as a small e value. It should be volume of voids to the volume of soil solids. If the soil has a more volume of voids means the void ratio should be maximum. That only I indicated here. Higher void ratio has a weaker soil because if void is more accumulated in particular of soil means the shear strength parameter should be decreases because it is not a compacted one, it is a loosely packed one. So because of loosely packed soil the forces does not distributed evenly, so the strength parameter should be neglected and shear strength also should be low. Next one is the porosity. Porosity means the total volume of voids to the total volume of soil mass. The first one volume of void ratio means V by Vs, that means volume of voids divided by volume of solids. Next one porosity means volume of voids to the total volume, that means Vv by V. So this is a major difference between them. It is related to the void ratio also. The next thing we discussed, I think one is the index properties. So these are the index properties. So first one water content we already discussed one. The next one specific gravity, that is also we discussed. The next one particle size distribution, that is also we already discussed. The next one consistency limits and the in situ density and density index. So let we discuss about the three portions here. So the first one consistency index. So when the dry soil is added by water, the soil behavior should be different based on the stages. One more diagram here. So initially I take one soil sample and I just added of water in terms of percentage. At the limit of shrinkage limit, the volume of soil should be increases. The graph should be clearly explained this one. When the water content is added, so much of portions that shrinkage limit, that means ws, after crossing ws the volume should be suddenly increases gradually. And next next thing is a plastic limit. In this plastic limit the soil normally in the shrinkage limit the soil is converted to the solids to semi-solid state. In the plastic limit the solid should be converted to semi-solid to plastic state. In the liquid limit the solid is converted to the plastic to liquid limit. So the each limit of this portion the soil has changes the consistency. So this is called as a consistency limit. When the soil turned solid to semi-solid portion means that particular maximum of water content, this is called as a shrinkage limit. And next thing, if the water crossing the when the water content is crossed the plastic limit, the portion of soil the consistency should be changes from the semi solid to plastic state. And when crossing the liquid limit, that means WL, the solid portion, the consistency should be changes from plastic to liquid state. So this one is only I clearly explained here. So that is a consistency limit. So consistency limit. The next one thing, plasticity index is normally derived from the difference between the liquid limit and the plastic limit. So based on the plasticity index, the soil should be examined by the deformation, because if the plasticity index higher means the deformation should be maximum. The next one is the grain size analysis. So based on the grain size analysis, the soil should be graded. That is used for the soil gradation also. When it is a coarse grained soil, means the sieve set analysis is there. When it is a fine soil means below 2 micrometer, it should be not possible to sieve set. So that much of soil particle should be grain size analyzed by hydrometer. This is also one method used in the laboratory also. And next thing one is the relative density, is the last property of index properties. So normally the formula index property is Emax minus E divided by Emax minus E minimum. Emax means maximum of void ratio. Maximum void ratio only occur in the loosest state of soil, and E minimum is a minimum of void ratio. So minimum of void ratio only occurs in the compacted. That means compacted means is a dumpest. That means dumpest state of soil, densest state of soil. That's only given to here. Relative density is a ratio between void ratio of loosest state to the natural state divided by difference between void ratio of maximum minus minimum. That means loosest state and densest state. The next thing is the classification system. Classification system, normally we followed a BIS soil classification system. BIS means Bureau of Indian Standard. So the soil type is gravel, sand, silt, clay, organic and peat. So the each soil type should be indicated by some of prefixes, that means G, S, M, C, O and PT. Okay, so the first two type, that means gravel and sand, is categorized as a fine, that means grain size soil. The next one is a silt, clay and organic. This much is a fine grain soil. So next subgroup is well graded, poorly graded, silt and clayey, and WPMC. The next three things is a plasticity ratio. Based on the plasticity ratio, the soil is a low, that means L, intermediate, that means I, and high plasticity, that means H. So initially, the red mark, that means the left side prefix red mark is gravel and sand, right? And right side of suffix red mark is W, P, M and C. So based on that, the soil should be categorized. So for example, the first type of soil is a well graded gravel, that means GW, and poorly graded gravel, that means GP, and silty gravel, that means GM, and clay gravel, that means GC. So initially the gravel should be has four types. And next one is the sand. Sand also has a four types, that means well graded sand, poorly graded sand, silty sand and clayey sand. Okay, so next one is a M, that means MCO. MCO means silt, clay and organic in the prefix portion, and the right side is the suffix portion is LIH. So these are the suffix portion. So the soil types is categorized under ML, MI and MH. That means low plasticity silt, and intermediate plasticity silt, and high plasticity silt. And next categorization of is CL, CI and CH. That means low plasticity of clay, and the intermediate plasticity of clay, and the high plasticity of clay. And next one is the OLOIOH. That means low plasticity of organic matters, and intermediate plasticity of organic matters, and high plasticity of organic matters. and last one is the peat. So these are the BAS soil classification system. And next one is the unified soil classification system. So it is based on the major divisions are the coarse grained soil and fine grained soils. So coarse grained soils is further divided into gravel and sand. So gravel is further divided into GW, GP, GM and GC. We already told that GW means well graded, GP is a poor graded, GM means silty gravel and GC is a clay gravel, and sand means SW, SP, SM and SC. So that means well graded and poorly graded and silty sand and silty clay. And fine grained soil means silt and clay. Both are when liquid limit is 50% means ML and CL. So these are the unified soil classification system. So from this unit we discussed about the soil formations and soil descriptions, and what are the phases of soils, and what are the behavior of soils, and what are the structure of soils. So mainly phase relationship we discussed elaborately. So based on the phase relationship the soils are examined, and next thing is the soil classification system and index properties also. I hopeful everyone understand with this concept. Thank you so much. Thank you.